Hi there. This is a video lesson covering ionic bonding, which is the topic of chapter 5. And some of these notes are going to be a little bit of review from previous chapters, so you've seen some of this stuff. Most of it will be new, but some of the beginning stuff here is review from previous chapters, um, including a definition of an ion. An ion is an atom or molecule that has a charge, either positive or negative, and they become ions by gaining or losing electrons. Two new terms for you, terms that you'll want to know for the exam: cation and anion. A lot of people want to say cation, but it is cation, and that is a positive ion. Metals form cations. Anion is the name of a negative ion, and nonmetals form anions. I'm going to go through the notes fairly quickly because you can just read them. I'm going to just point out the important stuff, and then I'll get right to some of the skills you'll need to know for this chapter. Octet rule, again, we've talked about that. Atoms want 0 or 8 valence electrons or outer electrons. A couple exceptions to that. Hydrogen and helium, they can't have 8, so their options are 0 or 2. Helium already has 2, so it's happy already. So is hydrogen and helium follow the duet rule. Another exception, or some exceptions to the octet rule, are some of the D and P block metals. And what I mean by D and P block metals is the D block is the center block here, and then the P block metals are the metals underneath the stairway. Remember, you have this bold line that divides the metals from the nonmetals. Metals are on the left, nonmetals on the right. So a lot of the metals underneath the stairway and in the D block, they don't necessarily follow the octet rule. It's more complicated than we get into this class. We will just call them variable charge metals. But any of those metals can be exceptions to the octet rule also. This pattern is on your periodic table, the periodic table I gave you. I have kind of a fancy digital version. It's a little cleaner looking with the charges up here. We'll get into, is it a plus minus 4? Some of these can actually be a plus 3, the metals down here, because metals become positive, non-metals become negative. That's how you decide whether it's a minus 4 or plus 4. We'll talk about that a little later, though. This is one of the most important patterns on the periodic table. This 1 plus 2 plus 3 plus 4 plus or minus, minus 3, minus 2, minus 1, 0. It's on your periodic table, though. You don't have to memorize it. We will use it a lot for this chapter, though. Moving on. Again, a lot of just kind of terms, terminology, definitions. The word salt in the kitchen means table salt, sodium chloride, the stuff you put on your french fries and popcorn. The term salt in the chemistry class, it's a much broader term. It can mean any ionic compound. So ionic compound, salt, those two terms are interchangeable. And an ionic compound is a compound formed through an exchange of electrons in the formation of ions. You get a positive ion, you get a negative ion, and in chemistry, opposites attract. So the positive and the negative attract, and they form a bond. It's often between a metal and a nonmetal. And this kind of these opposite charges, they repeat themselves over and over and over and over, and they make a crystalline structure to make a crystal, which we call lattice. And you can kind of see it in this diagram. We have a positive sodium attracts a negative chlorine, which attracts another positive sodium, which attracts another negative chlorine. Positive sodium attracts another negative chlorine, which attracts a positive sodium. And this repeats over and over and over and over, billions and billions of times, just to form a tiny little salt crystal. So one of those tiny little crystals that goes out of the salt shaker and into your popcorn has this pattern repeated billions and billions and billions and billions of times. And these are very strong bonds. And since they are very strong, most ionic compounds are solids at room temperatures. They have high melting points and boiling points, so it takes a lot of energy to break the bonds and make it into a liquid or a gas. And backtracking a little bit, why they're solids at room temperatures, they're held together very strongly, so they can't move around. That's the definition of a solid, is those particles are held very tightly, so there's no freedom of movement. There are also electrolytes, and electrolytes are substances that conduct electricity when melted or dissolved in water. You may have heard the word electrolyte before, like in Gatorade commercials and Powerade and all those kind of things. Well, the whole purpose of Gatorade and those types of sports drinks is when you sweat out water and you sweat out these salts. And supposedly the Gatorades and the Powerades and all those things, they replenish those salts because your body needs those salts for it to run smoothly. And they also replace the water that you're sweating out. Unit cell or formula unit, that's just the smallest repeating unit. So like this is a whole bunch of NAs and CLs, but the smallest repeating unit is 1 Na for every 1 Cl. So that's what we call the unit cell or formula unit. So we call it NaCl. And they want to be in a crystal. It's a lower state of energy for them to be in a crystal, so they want to be in a crystal. Atoms, ions, they're lazy. If they can be low energy, they're going to be lower energy. And so when they're alone, they're at higher energy. When they become a crystal, when they form this bond, after they form the bond, they're at lower energy. That means they have extra energy, and they release it, and that's what we call lattice energy. Okay. Polyatomic ion. Let's break down this word real quick. Poly means many. Atomic, meaning atom, and an ion. So it's an ion made of many atoms. Group of atoms held together tightly that act as a single unit. That is what a polyatomic ion is. Again, it acts as a single unit. I will give you a handout, and I'll put it up on the website, on the Moodle site. It's a list of polyatomic ions. You don't have to memorize them. It'll be kind of another resource along with your periodic table that you'll be able to use on all your tests, your worksheets, and stuff like that. I will post that as soon as possible up on the Moodle website. And these polyatomic ions, again, are groups of atoms held tightly together, and they act as a single unit. And that unit, that group of atoms, has an overall charge. It can be positive or negative. Most of the polyatomic ions we will use are negative. So, getting into the skills that you will learn for this chapter. Writing formulas for ionic compounds. You write the positive ion first, and again, you can figure out if it's going to be positive or negative from looking at your periodic table. If I have sodium, I know it's positive. If I have calcium, I know it's positive. If I have chlorine, or sulfur, or bromine, I know they're negative. I just look at the column that they're in, and that's the charge of ion that they will form. So positive ion first, then negative ion. Use the charges to find subscripts. And if a chemical ends in ate or ite, use the polyatomic ionic handout. Roman numerals equals the charge. Some of this stuff will be a little confusing at first, but once we get into it, I'll come back to these tips. So let's just jump right in. What I'm going to teach you how to do is something called the switch trick. So we have lithium and sulfur. Well, if I look, lithium is positive, sulfur is negative, so I know I want to put the positive one first. And another trick is it doesn't always work, but almost all the time, 99% of the time, the examples that we'll do in this class, you go from left to right on the periodic table. So again, we have lithium, which is a positive one, sulfur, negative 2. What I do is I write the symbols. 1 second. Okay, try this again. And again, I wrote the positive, lithium, then sulfur. And if you remember, lithium is a 1 plus. Sulfur is a 2 minus. Sorry about my little typo there. What I do is something called the switch trick. The number from the sulfur becomes the little number after the lithium. The number from the lithium becomes the little number after the sulfur. So I take just the number, not the charge, and it goes down here. I take the number, not the charge, just the number, and it goes down over here. See how they kind of switch? That's why I call it the switch trick. So the formula for lithium and sulfur together will be Li and S. And again, after the numbers switch, we end up with a 2 there. Now, there is a 1 here, because the 1 from the lithium, again, the 1 from the lithium came down here after the S, but you never write the 1s. And I think you all kind of already know that already, because if I write water, H2O, we have 2 H's, we have 1 O. Do we write the 1 here? You've never seen it written H2O1. We don't call it H2O1, we call it H2O. So we don't write the 1s. Just remember that, don't write the 1s. If it's anything other than a 1, you will write it. And if it's nothing there, we assume there's a 1 there. So let's do another example here. Beryllium and phosphorus. Beryllium, if I see on the periodic table over here, is a +2. Come on, why are you doing that? Seriously, why are you doing that? I don't know why it does that. That's really annoying. But again, beryllium is a 2 plus, and phosphorus is a 3 minus. Now I do the switch trick. The 3 from the phosphorus goes down behind the Be. The 2 from the Be goes down behind the phosphorus. So I get, for my final answer, Be3, P2. That's a 3. Sorry, it's kind of sloppy. That would be my formula for beryllium and phosphorus together. Do a couple more examples here before I run out of time. I got kind of tricky on this one. Oxygen and aluminum. If we look, aluminum is the positive here, so I didn't give you these two in the correct order. So aluminum is a 3 plus. Oxygen is a 2 minus. When I do the switch, I end up with Al2O3. I think that's where we're gonna cut it off for this video. I will pick up the next video with magnesium sulfate. Magnesium sulfate is a little bit different. It has one of those polyatomic ions in it. So I'll bring up that handout and we can take a look at that.